Again, welcome to Biostatistics 1. And this is a normal probability distribution lectures, which cover chapter 7 of our course textbook. Again, we are going to have our midterm exams, and our midterm exams is from chapter 3 to chapter 7, which is descriptive statistics and probabilities. The probabilities are 3 chapters. We cover the discrete probability distribution, which is chapter 6. Then we cover introduction to probabilities, where we talk about 3 different types of probabilities, chapter 5. And this is chapter 7, which is continuous probability distribution, which is, again, we cover only the normal probability distribution in this chapter. So our main objective is to go through what is the normal distributions, also to determine the normal probabilities, and finding values that correspond to normal probabilities. So first, what is a normal distributions? Normally, I would say a normal distribution is based on a continuous random variable. So a normal distribution is a continuous probability distribution, which means they are random variable. The values is based, again, on a measurement. Counting is discrete probability distribution. So continuous random variable values are based on measurements. And we have a normal probability density function. We covered this in chapter 5. So see lecture 5 about probability density functions. But we know that normal probability density functions are recognized by their familiar bear-shaped curve. And the bear-shaped curve, again, is the same as the normal distribution. So we'll see it here. So this is a bear-shaped curve, which is a normal distribution. One is a symmetrical at the center. So the center will be our mean. And one of the main properties of a normal distribution is that the mean and the media and also the mode, they are equal. So the mean equal to the media and mode. And this normally is at the center of the distribution. So the graph or the shape will be symmetrical around the center of the mean. And also the total area on that curve here is 1. And this is more or less a probability values. Probability values are from 0 to 1. So here we say the area under the curve. We have an example in the next slide, which we say the darker side, the blue section, means the ages are from 1 to 9. Or we say the ages are less than or equal to 9, which is almost 40% of the distribution. Then the rest, which will be roughly 60% of the distribution, will be the ages are from 9 or greater than 9. Or in this case, we say from 9 to 19. So this is, again, our normal distribution. Age less than or equal to 9 is from left 1 to 9. Greater to 9 will be from 9 to 19. So the main 2 parameters of a normal distribution is the mean and also the standard deviation. And that tells us the shape of the curve or the bear curve. So again, mean and the standard deviation. The mean controls the location. So if the mean value is bigger, the graph will shift to the right. If the mean value is less than previous value, then the graph location will change and it will shift to the left. The standard deviation will control the spread of the data. So when the standard deviation value is bigger, the graph becomes wider, or the bear-shaped curve becomes wider. When the standard deviation is very small, it becomes narrow. So we'll see example here. So first we start with the mean. We can see that mu1 is less than mu2. So it's at the left. Then mu2 is greater than mu1 and it's at the right. So when the mean value is increasing, again, the distribution or the bear-shaped curve will shift to the right. When the mean value is decreasing, it will shift to the left. So the mean again control the location of the bell-shaped curve. Also, when the standard deviation increase, the graph becomes wider. So curve 1, which is here, you can see that is very wider. Now, when the standard deviation is very small, the graph, the location is the same place, the mean is the same location, but we can see that curve 2 is narrowed and curve 1 is more spread, more wider. So it becomes wider when the standard deviation is bigger. Smaller, the spread, the standard deviation is smaller. So next we move to what is a standard deviation, and then we are going to follow the steps on finding the probability of a normal curve. So first, let's go to what is a point of inflection. Now, the point of inflection is where the slope of the curve begins to level. So let's go to the next slide. We can see the slope becomes start to level, and this is the point of inflection. This is when the mean minus or plus one standard deviation. So normally we have a rule that plus or minus one standard deviation of the mean will be 68% of the distribution. So here, this is the rule, 68% of the area under the curve falls between or within plus or minus one standard deviation of the mean. 95% will fall between 2 plus or minus of the mean, and 99.7% will fall within 3 plus or minus standard deviation of the mean. So let's see the next slide. So here we can see from mu minus one standard deviation to mu plus one standard deviation, the distribution is 68%. Now mu minus 2 standard deviation and mu plus 2 standard deviation, the distribution is 95%. The mu minus 3 standard deviation to the mu plus 3 standard deviation, the distribution is 99.7%. And we have a rule, we say 68, 95, and 99.7 rules. So here we have an example. An adult intelligence score was given to us, and they say the values, let's assume we have 20 adults that take intelligence score. So we have 20 different scores, and these values are distributed normally. The mean of all the score is 100, the standard deviation is 15. So the parameter again, the mean is 100, standard deviation is 15. Now, if we want to find 68% of the score will fall within which range? That means the range of 68%, the minimum to the maximum score. So that would be plus or minus one standard deviation of the mean. So mean plus or minus one standard deviation, which will give me the mean is 100, the standard deviation is 15. So we get 100 plus or minus 15, which means by this 68, 95, 99.7% rule, the scores, 68% of the scores will fall between 85 to 115. Then the same thing, we can find the 95% of the score. So that would be plus or minus 2 standard deviation of the mean. So that would be 100 plus or minus 2 times 15. And that will give us 2 times 15 is 30. So 30 from 100, and we add 30 to 100. So it will be between 70 to 130. And the last one, which is most of the data, will fall between plus or minus 3 standard deviation of the mean, almost 100% of the data, all the data. Here we have 99.7 because of, again, few percentage of error. But majority of the data will fall between 15 to 145 score. And when I say majority of the data, we mean the score of all the adults that took the intelligence score. Or the minimum value will be around 55. The maximum value will be around 145. So again, this is how we find the 68, 95, 99.7% distribution of data. That's if it's normally distributed. So this is our example in the next slide. As we said, we can see our score. The one standard deviation, we subtract 15 and add 15. So it's from 85 to 115. Two standard deviation is 2 times 15. So we subtract 30 and we had 30. And the value is 100. So we get 70 to 130. Then 3 standard deviation will be 3 times 15 will be 45, which means we subtract 45 from 100 and we add 45 to 100. So it will be between 55 to 145. So here we say the normal distribution is normally symmetry in the tails, which means it will get tiny on the tails, both the left and right tails, but it doesn't touch the x-axis. So here we say because of the normal curve is symmetrical and the total area under the curve adds to 1, we can determine the area under the curve in tails. Example, because 95% of curve is in mu plus or minus 2 standard deviation, then the rest of the 5% will be 2.5% to the right and 2.5% to the left. And this is the graph. So we have 95% of the distribution from 70 to 130. So remaining again 5%. So 2.5% to the right tail, 2.5% to the left tail. So let's see one more example here. This is for male height. We said that a male height is approximately normal with a mean of 70 inches and the standard deviation is 2.8. So these two data tell us that they give us any amount of male with their height. Let's say we have 30 males and their height, when we calculate all the 30 heights together, the average is 7.0 or 70, and the standard deviation is 2.8. Now, because of the 68, 95, and 99.7% rule, we can say 68% will fall on one standard deviation. So it will be 70. 70 is our mean again, our mean. So it will be 70 plus or minus 2.8. 2.8 is our standard deviation. So that gives us 67.2 to 72.8. Now, with 2 standard deviation, we get 95% distribution, which will be 70 plus or minus 2 times 2.8. And then 99.7% will be 3 standard deviation plus or minus. So it will be 70 plus or minus 3 times 2.8. Now here we say since the total area under the curves adds to 1, which is 100%, base here we can say 32% are in the tails below 67.2, which makes sense because again, the total, the 67.2 to 72.8 is 68%. So which means we have 68 from 100%, we have 32% left. So that's why I said because the total area under the curve has to 100. If we take 68% from 100, it leaves with 32. So we can say that the 32% are in the tails below 67.2 and above 72.8. So these 32% are out of this range. The other to the left after, before 67.2 or to the right after 72.8. So that's what we mean by below and above 72.8, which means to the right. Below 67.2 means to the left. Why? Because again, 68% is between 67.2 to 72.8. So starting 68% from 100%, we get 32%. So the 32% is out of this range, the range of 68%. Now, because of symmetry, we can divide again the 32% into half because it's symmetry. So what is in the left side of the mean should be the same as the right side of the mean. Since we have 32, then below the 60 and the value was 67.2 will be 60% of the data. And then above 72.8, will also be 60% of the data. Again, 32% we divide in, since it's symmetric, we divide the two values into two, distribute evenly to the right, to the left. So this is how it looks like. The 68% we find it. Our interval was 67.2 to 72.8. And we know the mean is at the center, which was given to us 70%. So if this is 68, again, this value is supposed to be 68. So if this is 68%, to the right will be 16%, to the left will be 16%. So the total will give us 100%. So again, this is 68, not 64. So now we finish with the theory behind normal probability distribution and how to find the distribution within 1, 2, and 3 standard deviation. Now the next step, we are going to learn how to determine the normal probabilities. So to determine the normal probabilities, when the value does not fall, again, we don't know where it falls anywhere in the range of the whole distribution, but it doesn't fall exactly at plus or minus 1 standard deviation or 2 standard deviation or 3. So this means it can fall anywhere within the graph. So the first step we need to do is to state the problem. So we need to state our problem. Then after we state our problem, we find a z-score. The goal of a z-score is to change the normal distribution to standard normal form. Now, when we have the z-score, we can go to the z-table, or sometimes called the standard normal table. So based on the z-score, we will get the p-value, the probability value in the table. In the course textbook we are using, the table is in table B, appendix B, and it's called table B. But again, any textbook, you just have to know the name of the table is either z-score table, or sometimes, most of the time, called the standard normal table. So let's see one example here. And again, here we say we want to determine the percentage of human gestations that are less than 40 weeks in length. So this is what we want to determine. We want to know that the human gestations are less than 40 weeks. Now, in order to solve normal probability question, the mean will be given to us. So in this question here, they say we know that uncomplicated human pregnancy from conception to birth is approximately normally distributed with a mean of 39 weeks, and the standard deviation is 9 weeks. Now, what is the probability that the human gestations will be less than 40 weeks? So that's what we want to find. So if that's the case, 40 weeks is our value. That's what we want to look, probability that it will be 40 weeks. But based on the data set given to us, the mean was 39 and the standard deviation was 2. So the first thing we can find is z-score. And then the z-score, as we said, the random variable x is less than or equal to 40. So 40 weeks. So this is a time. We cannot count time. We can measure a time. So we can see that the random variable is based on measurement, period of time. And the parameter given to us, the standard deviation, the mean is 39 and 2. So mean is 39, standard deviation is 2. So the first thing we have to look for is the z-score. So it's the standard normal variable, which is the z. So we know that with a standard normal variable, a normal random variable with mu 0 and the standard deviation of 0. This is called the z variables. And the notation will be 0 and 1. Again, the standard deviation should be 1, not 0, 1. With the standard normal variable, standard normal distribution, the random variable, we say that the mean should be 0 and the standard deviation should be 1. So we use the table B to look up the cumulative probability, which will be in our next slide. So this is how the table looks like. The table have a z value. Our first column is z value with only 1 decimal place. Now, if the z value is 2 decimal place, then you move it to from 0.00 to 0.09. So for example, if I'm looking for the z-score of 0.7, I will go to 0.7 here. And the first p-value is 0.7580. So this is the answer because in the first column it's only 0.00. So if it's one decimal place, the answer will be in the first column. Now if it's 0.72, I will go to 0.7 and I'll look for 0.02. So 0.02 is the third column. So the answer will be 0.7642. Again, the probability values here is from 0 to 1. So now let's solve our problem. If you remember, we said the mean was 39, the standard deviation was 2. We are looking for the probability that it will be less than 40. So if it's less than 40, when we get our value from the standard normal table or the Z table, we don't need to, the answer is correct because the table always gives us the answer from left to the number. Now, if it's greater, then when we get the answer from table, we are going to subtract it from 1 because it goes to the right. Then if it's between 2 standard deviation, then we find a Z for both. And then we find a P for both. Then we find the difference of the two. Again, we may discuss this soon. So in this our problem, what's the probability that the value is 40 or less? So I look for the Z value for 40, which will be 40 minus the mean over standard deviation. The answer is 0.5. Again, this is the formula Z equal to X will be our random variable, whatever value we are looking for, minus the mean over standard deviation. So here, we're going to the next thing we're going to do, we find the standard deviation and the answer was 0.5. So the next thing we have to look for the p-value based on 0.5. So here we say Z is less than or equal to 0.5, give us 0.6915. This will be our final answer because when you see the graph, we say less than 40, so it will go to the left area, so this area. And our table always gives us the value from the left to the value. Now, if I say it's greater than 0.5, then I'll go to the right, which means when I get 0.6915, the table is from left to the value, but I'm looking from the value to right. We know the total area under the curve is 1. So the answer will be 1 minus 0.6915. That's if probability that Z is greater than 0.5 or Z is greater than 40. So we go back again. After we get a Z value, we go straight to the table. The Z value is 0.5. So I'll look at the table B, which is the standard normal table. Look at 0.5. Okay, the answer is 0.6915. Since it's less, I'm not going to change it. That's the correct answer. So this is what we are trying to explain. Now, if I have two Z values, that means I'm looking for, let's say I'm looking for the value that, let's say the X random variable will be between 2 to 3. So I'm going to look for the Z value for 2, Z value for 3, then the P value using the standard normal table. I find the P value for A, the P value for B. Then I find the difference of B minus A. And that will give me the probability on the area that is shaded, because we have two X values, random values. So we find the random and use the random variables to find the two Z values. Use the two Z values to get the P values. Then we find the difference of B minus A. Now, if it's less than or equal to B, whatever we get from the table, that's final. So for example, as we said earlier, the B, we find it to the left, A, we find it. So to get this, it will be B minus A, because we want to cut the A part out, so we minus it. Okay, so the next we're going to learn how to find values corresponding to a normal probabilities. So here again, you state the problem, use the table B to look up the Z percentile value. Then you do your sketch, then you unstandardize with the formula. So Again, we do the one example, how to find the probabilities. Now, in this question, the probability will be given to us. We have to find the random variable x. So we are using the same formula. If I have z equal to x minus mean over standard deviation, if I do a formula transformation, remember it's x minus mu over standard deviation is z. So z will multiply by standard deviation equal to x minus mu. Now, if I take the x to the left side, then I'll get x equal to mu plus z multiplied by the standard deviation. So that's where we have this formula from. The formula was derived from z equal to x minus mu over standard deviation. So we have to look up the z percentile value. So in this case, when you go to the table, the example here, let's do, for example, they give me the p-value to be 58.5871. So what would be the z value? I will look to my left. My left is 0.2, and to the top is 0.02. So which means for 0.6255, the answer will be 0.32. For 0.5871, the answer will be 0.2 and a 2 again at the top. So these values at the top is 2 decimal places, and here is 1 decimal place. So 0.41 will give me 0.0124, so that will give me 0.6591. So finding the normal values. Now the question here, suppose we want to know what gestation length is less than 97.5%. So here we want to see the values that are less than 97.5% downward. So this means first, I will let the x represent the gestation length. That's what I'm looking for. Then we know the mean is given to us to be 39. The standard deviation is given to be 2. Now, in order to get a z, since we know the 0.975, we are going to use that in the table. So let's see the table. Well, let's go to the big table here. So if that is the case, I have a 0.975. Let's see if we can, yeah, it's right here somewhere. So we look at 0.975. We don't have it. So the highest we go here is 0.9678. So maybe, oh, okay, that's right here. So here we can see that it's 1.95.05. So I'm taking, for 975, I'll use 0.9744. Or here we have the 0.975. So 0.975 will give me 1.96. So that's what we are doing here. Again, this is our example here. We know the 0.975, which is 97.5%. So here it generates the z value to be 1.96 from the table. So if I know the z value, then I can find the x, because we know the x equal to what? The mu, which is given to be 39, plus the z value, and the z value was found based on 97.5, which was 1.96. So multiply by 1.96 times, again, the standard deviation. So let's see, the formula will be, so this is how we find negative 1.962. We go negative 1.9 row, then we look at 0.06. So this is the question again. S gives us the mean 39 plus the z value will be negative 1.96 times the standard deviation is 2. So we say that the random variable value for this condition, 2.5 percentile gestation 35 weeks, will be 35. So let's see some example here. So here we say we have a total cholesterol story in children aged from 10 to 15 is assumed to follow a normal distribution with a mean of 191 and standard deviation of 22.4. So first, what is the proportion of children 10 to 15 years of age have a total cholesterol between 180 and 190? So the question already told us this is a normal distribution. So we have to convert it to a standard normal, which means we have to find a z value. But this time, we are looking for the value that will be between 180 and 190. So we have to use 180 to get our first Z value. Then we use 190 to get our second Z value. So our two Z values will be 180 minus 191 over 22.4 and 190 minus 191 over 22.4. Based on the question, the standard deviation is 22.4 and also the mean is 191. So that's why we have the mean minus 191 minus 191. Now we are looking for the corresponding that fall between this range, 180 and 190. So we look for 180 for the Z, 190 for the Z. Then the answer we get, we look for the P. So negative 0.49 will give me a P value that will be 0.3121, 0.484840. Then negative 0.04 will give me 0.3121. So we find the difference of the two, and that will give us our solution. So again, when we are looking for a p-value that fall between two random variables, then we look for the two z-scores, then find the difference. Then we look for the probability in the standard normal table or the z table. So the B, we have B. B says what proportion of children 10 to 15 years of age will be classified as hyperlipidemic, assuming that hyperlipidemia is defined as a total cholesterol level over 200. So this means greater. So probability that S is greater than 200. Okay, we use the 200 to find our Z. So it will be 200 minus the mean 191 divided by standard deviation. And our answer was 0.40. So when we look at the table 0.40, we get 0.6554 for the probability. But because it's greater, that means we have to go to the right. So the answer we get from the table is from left to the answer. So we have to subtract it from 1, and that will give us 3.3446. Now we say that if a sample of 20 children is selected, so this time we are not going to use the population, we are going to use the sample. What is the probability that the mean cholesterol level in the sample will be 200? So the same thing, we use the 200 as to find our Z, but this time we are not going to use the population standard deviation. We are going to use the sample standard deviation. And the formula to find for the sample standard deviation will be the population deviation divided by the square root of the sample size. And the sample size is 20. So we have 22.4, which is the population standard deviation, divided by square root of 20, which is the sample size. Again, when you do this calculation, you get 1.8. Now look the standard normal table or the Z table. 1.8 will give me 0.9641. So I'll subtract the answer from 1. Since it's greater, I'm going to the right side. So if I'm going to the right side, the right tail, then I subtract from 1. So the final answer will be 0.0359. So this example is a very good example that when you look at the first A, it's between two values. So we have to look for the two Z's, and we have to look for the two P's. Then we find the difference to get the area between the 180 to 190. So find 180Z, 190Z, find 180P, 190P, then find the difference of the two. Now, if it's greater, then we go to the right side. We are going to the right side. So follow the same step, find a Z. But when you get a P, you have to subtract it from 1. The P will give you the value from the left to the value. So if I'm looking for probability that S is less than 200, and then that's what I will do. Now the next question said, if a sample of 20 children is selected, so now we are using a sample. So the sample standard deviation is the population standard deviation divided by square root of 20. So when we get the answer, our Z was 1.8. Go to the table, the Z table or the standard normal table. Now find the p-value. We get 0.9641, but greater than to the right, so we have to subtract the answer from 1. Same as we did in previous B also. So this will be the conclusion of our chapter 7 course textbook. In this chapter, we discuss about, again, normal distribution, or called the normal probability distribution. We said the normal distribution is continuous, which means the random variable is based on measurement. So it's continuous random variable. Then we also discuss the 2 parameters of the normal distribution, which is the mean of the curve and the standard deviation of the curve. The mean can change the location of the curve. The standard deviation can either make our curve widely, the variation is big, wide, or shrink very small if the standard deviation is very small. Then we were able to use the 68%, 95%, and 99.7% to find the distribution of the data, the intervals. Then we learn how to find the P, the probability in normal distribution, and we learn how to find the random variable X in normal probability distribution. So this will be our conclusion of chapter 7. Again, wish everybody the best. Thank you.